Well, welcome everyone. I'm Alison from the Postgraduate Association. We're very pleased to have Dr. Megan Lee here today that's going to take us through Statistics Can Be Fun. So this is the first of a four-part series that Megan's going to deliver every Wednesday morning. We are recording, so I'll upload the recording to our YouTube channel. And I encourage all of you to become a member of the Postgraduate Association. And in that way, we can keep all these great workshops going all year for students that are free for students. So welcome everyone. I'll post a few links in the chat box, and over to you, Megan. Thank you so much.
Thank you, Alison. Firstly, I would like to apologize. My video is not working for some reason today. I don't know why. It was working the last two workshops, so I don't know. I'll try and fix that before the next one. I also usually begin by reiterating what Alison said about the Southern Cross Postgraduate Association. I finished my PhD at Southern Cross Uni in 2022, so nearly 3 years ago. And to be honest, my journey was a little bit rocky, but the Southern Cross Postgraduate Association was always there to help support me through all the rockiness that I experienced. I also met a heap of really cool people and who were on the same journey as me, and they're my friends still to this day. We still catch up all the time. So there was a group of about, I think, 8 to 12 of us who all got together, did writing retreats up in the back of Byron Bay, and met up at the Praxis conference. And we're from all parts of Australia. We're all different ages as well, which is really interesting, from 20s all the way up to 70s. So I don't think that my PhD would have been the same experience without the Southern Cross Postgraduate Association. So I would highly recommend becoming a member. Yeah, it's just a great association. But we will continue on now. My name is Dr. Megan Lee. I am now working at Bond University as an assistant professor. My PhD focused on nutritional psychiatry, which is everything about food and mental health, which we will be looking at some live data today that I collected in 2023. If you want to email me about any statistics questions, feel free to do so. I also offer tutoring through the Southern Cross Postgraduate Association. So if you are in need of any statistical tutoring for your honours or your PhD, feel free to contact me. That does have a fee, but sometimes the SCPA has funding to cover that. If you are interested in seeing someone's progression from honours through to PhD through to becoming an academic, or you're interested in my research on food and mental health, follow me on my socials. You'll see all of my researchy stuff on there, and my website at Food Mood Doctor. Before we get into it today, let's first find out what sort of experience you all have with statistics. So the next 4 workshops, so this week and the next 3, are all basically tiered in experience level. So today is the very basic foundations of statistics, how we get statistics into our programs, our software programs from survey platforms or from experimental research, and how we clean the data up so that it's ready to be analysed. And this is the most important step of statistics. So I want to know from you, type into the chat box who you are, what degree you're doing, if you're doing a PhD or an honours thesis, what your topic is, and from zero experience, no experience at all, through to 5, I've had some experience with statistical software programs, to 10, I am the most experienced at statistical data. Please tell me on that scale where you kind of lie. So name, degree, what your thesis title is if you're doing one, and what is your level of experience from 0, no experience, through to 10, the most experience in statistics. Let's have a look. Debbie. Hi, Debbie. Lisa from COF's doing a PhD in the effects of wheelchair cushion on microclimate. I've analysed some data on SPS recently, but still don't think I fully understand it. Good, that's a good level to be coming in at. This week will be all about data cleaning and getting your data ready to be analysed. Next week, we will be covering descriptive statistics and some of the ways that we look at analysing the demographic data from our participants and seeing what our data looks like. And then the following weeks, we'll get into our more advanced statistics analysis where we can answer our research questions. Catherine, psychology honours thesis is experimental study of positive psychology. That's exciting. I teach positive psychology. It's one of my favourite things ever. I'm a 1, have theoretically used SPSS interpreting data, but have not used it myself. Okay, cool. That's good. Positive psych. That's very, very cool. What's the experiment entail? Anyone else would like to share? Betty, biomedical science, currently doing masters by thesis, had stats, SPSS in the first year of my biomed, but need to refresh my brain. Excellent. So the next 4 sessions will be a really good review and refresher of what you've already learned. Ambra, PhD on insight experiences in psychedelic assisted therapy. Very cool. I've done some stats in the past, been a bit rusty, would say a 4 out of a 10. Perfect. Ehab, doing a master's by thesis at Gold Coast on training construction workers for enhanced safety management. I have no statistics software data analysis experience. Okay, great. Debbie, PhD on nursing students' experience with primary health care education, looking at increasing the PHC workforce. I'd be about a 2 or a 3, some experience with a master's research project, but had a lot of help. Great. Oh, Catherine's positive psychology experiment is if psychoeducation interventions on gratitude and humor can improve positive effect. Cool. All right, we might get into it then. So today we will be covering quantitative data analysis. Over the last 2 weeks, we have been looking at qualitative data analysis. So if you are interested in exploring how to analyze data that contains words, go back to the last 2 weeks on the YouTube channel, Alison has, or you can go to my Food Mood Doctor website, they're on there as well, and just see if you're doing focus groups or interviews and you are looking to do an analysis of words, go back to those ones. Today we are covering quantitative data analysis. Quantitative data analysis is all about numbers. But today we're going to start from the very foundations of what to do to start analysing data. So we're going to talk about the different types of research designs, variables and hypotheses. So we're really talking about terminology that's really important depending on what type of research design that you use. We will talk about the levels of measurement, which are really, really important when we go to analyse data. Then we are going to do a live data clean of a data set that I collected in 2023. So there will be, as is usual in statistics, it's going to be messy. It's going to be raw data. It's not going to be created for a workshop where it's all nice and neat. It's going to be exactly how messy data is. So we'll also have some hands-on experience with decision making around what to do in a data clean. And decisions will always be different depending on your research and your team. So I would highly recommend any decision making that you do in your thesis should be done with your supervisors. And then we will be looking at creating and transforming variables in SPSS. Hands up here who has access to SPSS on their computers. David is doing a master's degree in information technology and wanting to enhance his knowledge in stats. Maybe I should ask, is there anyone here who doesn't have SPSS on their computer? It's not really needed today, but we might be able to use in the next 3 workshops if everybody has SPSS. It doesn't look like it. Okay, that's fine. So every student who is doing a thesis should be able to access SPSS through SCU. So maybe in the next week or so, look at getting IT to pop those on your computers potentially. SPSS is the program, the software program that we use to analyze data. We will have a look at it today, but it will be a basic run through in how SPSS works, rather than actually using it, but it might be helpful in the following workshops. So let's just start out with the very basics, understanding research design. So we have several different types of designs, and they are analyzed using statistics in different and similar ways. So the first and the gold standard of research is our experimental design. Usually a randomized controlled trial is the best type of experimental design, and it's one of the only ways that we can really say or assume causality of one thing from another. So a randomized control trial is purely where we get 2 groups of participants. One group of participants receives an intervention. So the example that we use today is going to be dietary patterns and depression. So say the first group is given a healthy diet for 6 weeks, and the second group is our control group. The control group doesn't do anything. They don't change their diet. They just stay on the same diet that they're used to. So the traditional Western style dietary pattern that we have here in Australia, they would stay on that. And then at the end of the control trial, after the 6 weeks, we would measure people's depressive symptoms using a pre-validated scale or another means. And we would see if their depression changed from the 6 weeks of healthy eating and whether the control group changed as well. Just controlling for people whose depression would decrease, not because of a healthy diet, but just because of spontaneous reasons. So that's our experimental design, so randomized control trial. The second type is a quasi-experimental design. Quasi-experiments are done when it would be immoral or impossible to manipulate the variables. So in the diet example, we are manipulating diet by giving a group of people a healthy diet and letting the other group of people eat the normal way that they usually eat. In a quasi-experimental design, an example of this would be if it was immoral or impossible to manipulate the variable. So if we were to look at, say, let me think, an immoral or impossible type of experimental design would be to make people eat McDonald's for 30 days, like Morgan Spurlock did in his documentary. It would be immoral to do that because of the physical detriments that we know that eating McDonald's for 30 days would cause. So ethics would never let us do that. They would never let us get one group to eat McDonald's for 30 days, one group to eat healthy for 30 days, and then have a control group. They would never let us do that. It's immoral, and it could cause physical health problems. So what we would do is we would find people in the natural environment who already eat only McDonald's and compare them to groups who already eat, say, a healthy Mediterranean diet, and compare them to another group who eats a normal Western style dietary pattern. That's quasi-experimental because the manipulation of the variable diet is already naturally present in the environment. So that's quasi-experimental. So the researcher doesn't actually manipulate that variable, it occurs naturally. Then we've got our correlational design, which is up there in the top right-hand corner. Correlational designs are usually survey style research. So if I'm interested in diet and depression, I could create a survey that has demographics, age, gender, weight, height, geographical location, marital status of the participant, and then a battery of survey questions asking about diet quality, whether they eat a healthy diet or an unhealthy diet, and then a battery of questions that ask about depressive symptoms. In a correlational design, because the data is self-report, we have some issues with people self-reporting data in a way that is socially desirable. So I eat 2 fruit and 5 vegetables a day is a usual thing, and missing out on maybe a Mars bar or two if they have had that. So there are some issues with correlational design, and we cannot say that diet causes depression to increase or decrease using a correlational design. All we can say is that there might be a relationship between the questions that were reported on diet quality and the questions that were reported on depressive symptoms. Whereas with our experimental designs, we are able to say that changing the diet caused the decrease or increase in depressive symptoms. We've also got our descriptive designs. Our descriptive designs are more those focus groups and interviews that we use qualitative analysis to interpret, but you can also take qualitative data and analyze it quantitatively by counting the number of words or utterances in, say, historical newspapers, the amount of times the word postpartum comes up on a certain Facebook post or set of comments, things like that. So descriptive designs can be used with quantitative analysis as well. And the final research design that we have there is a meta-analysis. A meta-analysis is a research design where we take all of the evidence that has ever been written on one topic and we analyze the data across that. So say we have 10 experimental designs on diet and depression that have been conducted over the last 10 years. We take all 10 of those studies and we put their findings into a software program, and we analyze the findings to see if their results were consistent or not consistent. And a meta-analysis can then say, across all of these experimental designs, this is what we know about diet and depression. So it can be a very strong way of analyzing and synthesizing the literature. Do we have any questions about research design before we move on? Okay. So the next thing that we need to do before we analyze data is we need to come up with a research question, hypotheses, and identify what our variables are. Now, a variable is anything that we measure that can change. So diet is a variable because we can manipulate diet and we can measure the change. Depression is a variable because we can measure the change in depression from our manipulation of diet. What is the most important thing for everybody who is either doing an honours thesis, a master's thesis, or a PhD thesis is always having your research question and your research hypotheses clear from the beginning of your study before you start to collect data, before you start to analyze data. It's so important to be very clear about your research question and your research hypotheses. In our workshop that we did on systematic reviews and searching for systematic reviews, we talked about using PICO, Population Intervention Comparator Outcome, to develop your research question. So if you would like to go back to that workshop back in week 1, also on the YouTube channel, to see how to develop that and create a research question, feel free to review that. Okay. So we're going to have a practice at developing research hypotheses from a research question. What I would recommend, particularly for PhD students where you have your overall PhD research question, is to break each of your chapters down into research questions as well. So if you're doing a systematic review or a scoping review, have a research question for that. If you're doing some form of experimental design, have a research question for that. If you are doing a cross-sectional analysis of a survey, have a research question for that. And from the very beginning of your PhD, write those down on a sticky note and put them somewhere where you can see them at all times. So whenever you're reading the literature, you can come back and make sure that each piece of literature that you're reading is answering your research question and that your mind is always focused on your research question. Right, once we have the research question, we turn that into a hypothesis or an educated assumption of what we will find. So this is really important as well, knowing kind of what direction you think your results will go. And then identifying what the predictors and outcome variables are in those. So let's have a practice at doing a research hypothesis. So it is very important to understand that a hypothesis is not basically a guess. It is a fully educated assumption about what you will find, and it is always informed by theory and research, which is why it is really important to always read the literature before you start any form of analysis and understand the theory and background behind. So our first example. Our research question is there a relationship between diet quality and depressive symptoms in those who eat a plant-based diet? So to change our research question to a hypothesis, we need to say what direction and what we think will happen. So if you will have a little bit of a practice at changing that research question into a hypothesis, and we'll see how we go. Type that into the chat box for me. Lisa, people who have a plant-based diet have less depressive symptoms. That's close. We're missing a variable in there though. Susan, very good. People who have better quality of diet will have less depressive symptoms. That's good. Now, it's really interesting. You will see here in this research question, you have your population, plant-based dietary followers. You have your intervention, which is diet quality. That's the one that we manipulate. We have our outcome, which is depressive symptoms. And we also have a comparator. So we have kind of low and high diet quality resting in there as well. Individuals who follow a plant-based diet with lower diet quality will exhibit more depressive symptoms compared to those with higher diet quality. That's also very good, Udi. Excellent. Very well done. So let's have a look at our second research question. Do vegans or vegetarians have higher rates of depressive symptoms? What would our hypothesis be for this question? Lisa Cousins, vegans have higher rates of depressive symptoms? Vegans experience higher rates of depression than vegetarians? That's both are good hypotheses. Why do we think that vegans have higher rates of depression? Just curious, because this is the research that I do. Ooh, Ambra, very good. Vegans and vegetarians have different levels of depressive symptoms. So from the literature, if you don't feel that there is a specific direction, you can do a non-directional hypothesis like Ambra has done. Very good. Ah, just put it down as it was first, just a guess. Okay. So, and this is exactly what we should be doing at this stage of our research design. It is an educated guess. What does the literature say? Well, the literature doesn't really tell us whether vegans or vegetarians have a higher rates of depressive symptoms. We're not sure. We need to analyze our data to find that out. Yeah. Less nutrients because they don't eat eggs. Interesting. Right. So we can't answer our question yet. We're just making this educated assumption. Debbie's joking. That's okay. Right. So our predictor and our outcome variables. So let's talk a little bit about terminology here. So we've seen here in our hypotheses and our research question, we had a population, we had an intervention, and we had an outcome. So when we are looking at analyzing our data, we need to be able to identify in a research question or in a hypothesis which of the variables is the predictor and which is the outcome variable. Now, you may have heard the terms independent and dependent variable. These are the same as predictor and outcome. It is only correct to use the words independent and dependent variable in experimental design. The definition of an independent variable is a variable that the researcher manipulates to see the change in the dependent variable. Now that's correct for experimental research, but for surveys and other types of non-experimental designs, the correct terminology is predictor and outcome, but they are used interchangeably throughout the literature. So keep your eye on that. Welcome to the world of data analysis, where there are several different names for things that are the same. So let's have a look. If we have a think about what our definitions are for predictor and outcome, the predictor is the variable that we change or is manipulated in an experimental design, and the outcome is the variable that we see the change in. So for these examples here, what is the predictor and outcome variable? Is there a relationship between diet quality and depressive symptoms in those who eat a plant-based diet? Let's look at that one first. Which is the predictor variable and which is the outcome variable in the first question? Predictor variable is diet. Yes. IV is diet quality, DV is depressive symptoms. Now that would be correct, Amber, if we were doing a experimental research design, but there's a little tip in the research question that suggests that this might not be experimental. The word relationship suggests that this is a survey design because we're looking at the relationship between the diet quality and depressive symptoms rather than manipulating or doing an experiment where we're trying to find whether diet quality causes depressive symptoms to increase or decrease. But they are in the correct order. And what about for our second example? Do vegans or vegetarians have higher rates of depressive symptoms? What's our predictor and our outcome variable in this example? This one actually could be experimental design if we took vegans and vegetarians and rated their depressive symptoms. Very good. So the outcome is still depressive symptoms, or the dependent variable is still depressive symptoms. And the predictor variable is actually the group, the difference between vegans and vegetarians. So group with two categories, which makes me feel like it might be more of an experimental design. Great work. So the next thing that is really, really important before we get into data cleaning, before we get into analyzing our data, is understanding the 4 different levels of measurement. And we're going to have a little bit of an example and activity after this slide, where we try and see which ones are which. So the reason this is important is because when we put our data into the data software program, we need to nominate to the software program which level of measurement each of our variables are. Sometimes the program gets it wrong and we need to adjust and change that. If you try to analyze data in the wrong level of measurement, it will not work and you will get incorrect data. So this is the very first thing that we check when we start cleaning our data, is our levels of measurement are correct. So there are 4 levels. There are 2 categorical variables and 2 continuous variables. Categorical variables, as the name suggests, are variables that can be organized into categories. Continuous variables are variables that lie on a continuum. So think like a ruler whenever you think of continuous variables. They can go from infinity, negative infinity, through to 0, all the way up to positive infinity on a ruler. This means that they also can have decimal places, whereas categories tend to not be able to be decimalized. So our first level of measurement is nominal. It's categories and they can be labeled. So nominal can be things like gender is a common nominal variable, categorized. There's no order in the categories. Political leanings, also geographical location can be a categorical data. There's no order to them, they're just categories. Very easy. The next level of measurement is ordinal data. It's also categorical, but there is some form of order to the measurement. So, for example, a grade level, so fail, pass, credit, distinction, HD are ordinal data because there is a distinct order to the categories. The same as where you come in a race, that's ordinal. So it's ranked in order. Your category is ranked in order. Then we have our 2 continuous variables, interval and ratio, that can fall on that ruler, on that continuum. Interval data has known equal intervals between each of the distances, but ratio data doesn't have that. Interval data does not have a true 0, which means that it can fall beneath 0. Ratio data, and the way that I remember it, is that it has a true 0 because it has a 0 on the end of the word ratio. That's taken me a little time to remember that. What that means is having a true 0 means that at 0 there is nothing. Whereas with interval data, you can have negative values. But say height is a ratio data. So at 0, there is no height. You can't be negative height. Same with weight. And age, I think also. Very good. So let's have a try at guessing these levels of measurement. So number 1, what is your age? 18 to 29, 30 to 59, or 60 plus? If this variable was in a survey, what type of variable would that be? Nominal, ordinal, interval, or ratio? Ordinal, good. Yes, because they're categories and they're in an order. Great work, Susan. Our second question, how many children do you have? And then you write how many children you have. Nominal, ordinal, interval, or ratio data? Nominal, not quite. Nominal is a categorical data. So if I asked you how many children you had, could it fit on a ruler? Interval, does it have a true 0? At 0, is there none of the variable, or could you have negative children? Ratio, good, Catherine and Debbie. Excellent. Yes, it is ratio data. You can't have negative children. What is your race? And then you put your race into the box. You free type that in. Nominal, I would say so, yeah. How old are you? Nominal, ordinal, interval, or ratio? Ratio, good. True 0, you can't be negative age. What is the highest level of school you have completed? Less than high school, bachelor, master's, PhD. Other is kind of throwing that variable out, but I would remove that anyway when we did our data cleaning. Ordinal, good, yes, because there is a distinct order to those categories. We've got age again, 0 to 19, 20 to 39, 40 to 59, 60 to 79, 80 to 99, 100 to 119. Ratio, Udi, why do you think it's ratio data? It's a tricky one, this one, because you could actually analyze this as ratio data or as ordinal data, which is very interesting depending on what your research question is. What about what is your political affiliation? And you would then type in what political affiliation you are there. Nominal, great, excellent. And then overall, the educator is effective in this subject with our smiley faces. I'd say that one's nominal as well. Interesting. Great. So now that we understand our levels of measurement, we can move on to cleaning our data. So I'm going to show you two ways of cleaning data, one in Excel and how to export your data from a survey platform into either Excel or SPSS. I'm going to show you both ways, and then I'm going to do a data clean in SPSS because I don't really recommend doing it in Excel for several reasons, because SPSS is just a little bit more user-friendly, but you can, and I know lots of people who clean in Excel and then transport it into SPSS, or clean in Excel and put it into another data program. So let's go and have a look. So I'm going to show you a live data set that we collected in March of 2023. We are still writing this paper up because we found some really interesting findings. So we were looking for vegans and vegetarians who have been vegan or vegetarian for their entire lives. And the reason that we were doing this particularly was because a lot of the cross-sectional surveys that we had done previously on vegans and vegetarians, particularly in Australia, when we asked them about diet quality, they were actually nominating that they ate meat sometimes in the food frequency questionnaire, which went against them self-reporting as vegan or vegetarian. So we were having troubles with that. So to fix that problem, we decided to only recruit participants who had been vegetarian or vegan for their entire life, usually because of religious or upbringing cultural reasons. So myself and my collaborator Gurmeet, who is from India, we measured and we collected data from both Australia and Indian populations, and we found some really interesting information. So when we ran the analysis, we found that the Western-based population, there was those who had a high quality diet had decreased depressive symptoms, and those with a low quality diet had increased depressive symptoms. But we didn't find that for the Indian-based population. So we're still working through the analysis and trying to interpret what was going on, which is really exciting and interesting. So we're going to play around with that data today. So let's do that. The first thing I'm going to teach you is how to export from Qualtrics. And don't worry, we'll do this very slowly. Then I'll show you about data cleaning in Excel. So if there are some of you who would like to do that, I'll show you a little bit how to do that. Very simple. Then I'll show you how to clean data in SPSS. It's heaps easier in SPSS, so I'll show you how to do that. But as the slides say, don't panic. There's so much information that comes from raw data. We delete most of it, so don't panic when you see lots of data. Then I'm going to show you how to clean your demographics so that they are all nicely demonstrated for your analysis next week. I'll also show you how you can compute a new variable. So in the example, our participants told us their height and their weight, and I'll show you how to compute a variable for BMI. Then I'm going to show you how to take a scale. This one is the Center of Epidemiological Studies for Depression scale. And I'm going to show you how to turn, say, a 20-question battery into one total score for each participant for depression so that you can analyze their depression compared to the other participants. And in doing that, I'm going to show you how to reverse code questions, because most battery questions have reverse coded questions in there to find out if people are malingering or not. Then we're going to create the total score for depression, and that will set us up for next time when we, for next week's workshop, where we will do descriptive statistics and some of the easier statistics where we analyze for research questions. So let's go back to the very beginning, our Qualtrics survey. Now, this is not a workshop on how to use Qualtrics itself. We are doing a Qualtrics workshop if you would like to learn the ins and outs of how Qualtrics works and how to develop a survey in Qualtrics on the 16th of April, I believe. Alison, if that's correct. I think so. I checked that this morning.
I'll just double check for you. Yep.
Okay. While you're doing that, I'm going to change my screen to my Qualtrics screen and we will move through this. Right. So let's see if this will work. Can everybody see my Google Chrome, my Bond University landing page before we move on? Yay, woohoo! Okay, now tell me if you can see the landing page for Qualtrics.
Yes, it's there. No worries.
Yeah, great. Okay. At any time, if I'm explaining something and it looks like my page hasn't moved, let me know. That
Yeah.
happens sometimes. So landing page for Qualtrics, very simple. Click on the lines at the top, go to your projects. This is where all your projects are housed. Active ones that are still open are in green. Ones that you've closed and are no longer collecting data are in grey. We are looking at the association between vegetarian for adult life, dietary patterns, and depression today. So I'll open that survey. As I said, the Qualtrics workshop that Alison has now put the link in the chat box. So if you want to register for that, feel free. We will go through how to develop a survey in Qualtrics in that workshop, how to create each variable, how to score them, things like that, so it becomes easy at data cleaning. As you see here, we've got demographics of our participants, we've got the depression battery, then we've got the diet quality battery in there as well. There's lots of questions on diet quality. This one is on social connectedness, sleep quality, depression, anxiety, stress, and physical activity. So they're all the questions that we popped into our survey. Today we'll only really be looking at the demographics and the diet and the depressive symptoms, but in future workshops we will have a look at the diet quality stuff as well. So all you need to know today is that we want to take the data that we've collected. So there was 610 participants, I think, that have completed or opened the survey, I would say, because there are some missing data. You will see here, this participant here in this row accessed on the 6th of April and didn't complete any of the questions. Sometimes this is your research team. Very often when you want to share your link to your participants or potential participants, you will click the link to the survey to share the link to your participants and it will create a new participant, and most of the time it's your research team. But then you can also see here is a participant who accessed their survey on the 30th of March, 25 years old, 170 centimeters. They consumed a plant-based diet. They're single, they're vegan.
I'll go now.
Hello?
Has someone got a question, or we've just got to mute some mics?
Why is the data called a battery? Is it like a lot of battery of data? So just the pre-validated scales have, so for depression, there's 20 different questions in it. It's a battery of questions. We take those questions and turn it into one continuous score for each participant. So although it looks like participants have answered a lot of questions, we turn those into very streamlined variables, and I'll show you how to do that. All right, so we've got all of our participants. We want to export the data. First of all, I'll show you how to export into Excel. So you just click, I'll go back, export and import, export data, Excel, download. Now, remember that this workshop is recorded. So when you start to do this for yourself, you can go back through the recording and follow exactly the steps that I took in the workshop. And you can fast forward me, you can rewind me, you can pause me. So it's really beneficial to, if you want to do this step by step when you are cleaning your data. So Excel, save it somewhere on your computer as, I'm going to call it Veg for Life, Excel, save. Build this open. Can you see the folder, the Excel on this screen? No. Okay. I'll stop sharing and I'll reshare Excel then. Share. Now can you see it? Yay, woohoo. Okay. As the slide said, don't panic. It looks like a lot of data. It looks really messy. There's words, there's numbers. Don't worry. Cleaning the data, we get rid of most of it. So if you have a look here, we just expand these ones that have asterisks in them. We have the date that the participant started the survey. We have the date the participant ended the survey. We have what type of status response. We have how much progress. So they did 100% of the survey. They finished 100% of the questions. How long it took them. Was it a true finish or did they exit halfway through? What date was it recorded when they finished? A response code, whether it was anonymous. They should all be anonymous because we set that up in Qualtrics that way. And then we've got a capture response, whether you're a human or a computer. I don't ever use any of this information, but if any of the start dates or progress reports are important to you, you can keep them. So I would go all the way up to the recapture. First, click on the top of the A column, hold down Shift and click on the top of the K column, which will highlight the entire thing. Right click, delete. Off they go. So that's all gone now. Now you'll see here in Excel that each participant is a row. Each participant is a row, and each of our questions in our survey is a column. So the first column that we have is, have you consumed a plant-based or vegetarian diet your whole adult life? Now, this was our inclusion-exclusion criteria for our study. If they were not a vegan or a vegetarian for their entire life, they got booted out of the survey immediately with a nice little message saying, sorry, you do not fit the inclusion criteria, or something like that. So anyone who's a no will get cleaned out of the data. So we would erase anyone who has that because they have completed the first question, but none of the rest. But you'll also see here, participant here, who has said yes to that question and has gone through the rest of the data. Male, 34 years old, 170 centimeters tall, 90 kilos, from the United States, who's single, has completed a bachelor's degree, who is vegan, and then the battery of depression, symptom questions, etc. start. So you can clean data in Excel and get rid of all of these no's and things, but I find that doing it in SPSS is so much easier and so much more streamlined. So I'm going to show you how to do that probably after the break. So it's 4 minutes to now. Once we come back from the break, we will export into SPSS, and then we will go through a full data clean, how to make decisions about things, and things like that. If that's all right, Alison, we'll come back at 5 past the hour.
Absolutely. Sounds good. Okay, so I'll pause and do you want to pause now? Or
Yeah.
yeah, okay. Okay, I'll pause now and we'll come back at 5 past.